bring Victor up right now. And I wanted, well, Victor is our STEM director and also as well as our co-director of our program. So Victor, it's all yours.
All right.
Y'all got to put your science, math, and technology caps on with Victor.
You want me to stand in the middle?
Yes.
Yes, sir. All right. Good morning, everyone.
Good morning.
My name is Victor McKen, and as Percy just so warmly introduced me, I am the STEM director for this organization. And I am really, really happy to be here this morning. I brought one of my proteges along with me, someone who is a student in mechanical engineering at Northeastern University, and he's going to give you a taste of what we're going to get involved in the new year, 2014, starting on January the 7th. So the way this is going to work is this STEM program is going to meet for 200 minutes of instruction every week. An hour on Tuesday, an hour on Thursday, and about 80 minutes on a Saturday. We're going to cover physics, the concepts of physics, all the way from vectors, all the way to heat theory and electromagnetism, and everything in between. Conservation of energy, conservation of momentum. We're going to talk about work. We're going to talk about torque. We're going to talk about electric charges. We're going to build circuits, and now when we build the circuits, you'll have a better understanding of what some of these concepts are, like resistance and current and voltage, all right? So I need you to help me to identify other mentors, other instructors like me to help out in this program. So without any further ado, I want Andrew to come up, and he's going to demonstrate to you what our textbook is going to allow the students to do. Because I won't be with the students for that whole hour that they're going through their lesson. But they will have online access to tutorial which will help them to do their assignment, all right? If they have problems in a specific area with the mathematics, we also have the Khan Academy that we're going to access to help them fill in the gaps of where they're deficient. So at this time, I'm going to ask Andrew to demonstrate what the Pearson textbook will allow us to do. And
I'm Andrew, everyone.
this is Andrew.
Welcome, Andrew.
Yeah, I work with Victor at Raytheon every day, and it's quite the rewarding experience, I feel like. I feel very lucky to be there, actually, in my position as well, being a student and getting to work at Raytheon, and especially with Victor because he's a great guy. Even though sometimes I bug him with all the questions I ask, but
He asks a lot of questions.
I ask a lot of questions. But
That's a good thing.
it's a good thing. So the great thing about this, I'm going to pull this one up. This is the website, and the great thing about it is, I think, it works with your textbook. So each student will have a textbook, and they can go to this website basically for help. It also helps you work through the problems that you're doing for homework, etc. So this is chapter 3. This is projectile motion, and you can see if they're kind of stuck on a theory or an idea, they can come here and see it says video tutor demonstrations, and it actually will show you kind of a concept, real-world concept of how one of these theories works. So we could watch one actually. They're very short, like 30 seconds, and they kind of just explain. So basically, yeah, right now he's kind of doing the Galileo's experiment where he drops two things, they fall at the same time. And we could watch it. It's
So
a very
here I
good
am up on a
demonstration.
12-foot ladder. I have 2 bocce balls. What I'm going to do while I'm up here is I'm going to throw this bocce ball straight off to my side, while at the same time drop this bocce ball straight down. The question is, which ball hits the ground first? The one that I throw off to my side, the one that I let drop straight down, or they both hit at the same time?
So now here they ask you, again, this is kind of trying to build on that theory. So they ask you, what is the answer? I'm going to cheat because I already know the answer, but they both fall at the same time. But then they'll show you how it works.
So as you can see, they both hit the ground at the same time. Well, how did this happen? Well, after I let both balls go, the only thing acting on them was gravity. Therefore, they both fell at the same rate. It didn't matter that I gave one ball some component of velocity in the horizontal direction. That's not affected by gravity whatsoever. Only motion in the vertical direction is affected by gravity. Therefore, I could throw the ball as hard as I wanted off to the side, and it would still hit the ground at the same time as the ball that I dropped straight.
So that's kind of an example of a video, kind of trying to build on that theory so you understand. And then I also wanted to show a problem. Now these are in the book, in the textbook, these problems, and they're examples. And when you're going through them, say you're lost or you're stuck, he actually writes out through the problem, talks you through it. So this is only 2 minutes. I'll just show you what it kind of looks like.
Now, please keep in mind that this is at a
Example
university
3.1,
level.
we're gonna-
What we're going to be using is at the high school level.
Yes.
Same concept.
Calculate the maximum height horizontal range with a projectile that's launched with an arbitrary initial speed v0 and an arbitrary initial angle alpha. This is very similar to the previous example. However, this will essentially be an algebraic calculation. We can still use the same diagram where T1 represents the time at which it reaches the maximum height, and T2 is the time at which it returns back to ground level. So, utilizing some of the results from the previous example, we found that the time to reach the maximum height was the initial velocity in the y direction divided by g, and this can be plugged into the height versus time, where of course the initial velocity in the y direction is going to be v0 times sine alpha. So plugging in this for the time, here's the initial velocity, here's the time squared, and collecting terms, we end up with this expression for the maximum height.
So we didn't have to watch the whole thing.
Right.
But I just want to give you a feel. He really walks you through it, explains how you get it. And for me, at least, I didn't always get the problem on the first try. I don't know about anyone else, but so this really helped me kind of fully understand. So I'd always come to this website, helps you with your homework. So I think it's a great tool to use.
Great. So now, this is pretty much wrapping up what I had to present to you. I just want to let you know we are starting January the 7th. We have a criteria that we're going through to down select the students that are going to be part of this STEM program. We want to start out initially with just 10 students. We want the students to make a commitment to us because we're going to be making a commitment to them. We have a proposal in play with a corporation called Ymss, and we're asking them to give us funds so that we can provide the students part of the STEM program with a tablet, with a graphing calculator, with a textbook that has access to this online access. And again, we're going to be giving them 200 minutes of instruction every week. So we will be taking field trips. We will be doing things to help them to light that fire in themselves. Now, I always say that I can inspire somebody, but I can't put that motivation. I can't put that burn in your belly. So I need you to help me find people that will understand the value of what we're offering here, all right? And this is a tremendous. So if you have any questions, please come and see me after this meeting. Handle.
Is there a target age group?
Yes, thank you. 8th and 9th graders are who we're targeting. Now, that doesn't mean we're going to exclude people who are not in the 8th and 9th grades. If we are having difficulty getting numbers, we will take people who are not in the 8th and 9th grade. That's it. Thank you very much.